Hi, this is Cassian with Instaclustr, now part of Spot by NetApp. Do you find yourself in an event or a conference and you need to be able to chat about Apache Cassandra? This video series is designed to give you enough information to be able to hold a strong conversation about various technologies, starting with the Cassandra database, including what it is, how it differs from other databases, and some use cases. In this video, we'll cover what Apache Cassandra, or what we'll call Cassandra, is, the fascinating history behind its development, just what makes it a truly unique database, and finally, dip into some use cases. When we talk about Cassandra, we are essentially talking about an open source database technology. However, there are many things that make Cassandra great. Cassandra is an open source, NoSQL, or not only SQL, database. It is distributed, decentralized, scalable, has tunable consistency, and is highly fault tolerant. Before we dive into each of these things, let's talk about the history of Cassandra. The initial development of Cassandra began at Facebook in the late 2000s to power their inbox search feature. This database had to handle lots of writes, tons of data, and across multiple, often distributed servers. In 2008, Facebook released Cassandra as an open source project via Google Code, and about a year later, in March 2009, Cassandra became Apache Cassandra and joined the Apache Software Foundation as an incubator project. A link to more about the Apache Software Foundation can be found in the description. In February 2010, it became a top-level project where it remains today. As of this recording, Cassandra is on version 4.1.1, released in March 2023. Let's get into what makes Cassandra special. It's open source, column-oriented, is a NoSQL database, and has some different methodology around data modeling. Cassandra is an open source project under the Apache 2.0 license. This means that anyone can contribute to the development of Cassandra and inspect the source code at any time. This allows users to both help shape the features and development of Cassandra, as well as knowing their software comes from a trusted source. Cassandra's data model uses a wide column store, which uses tables, rows, and columns like a relational database, but the names and format of the columns may differ between rows. It's common to think of it as a two-dimensional key-value store at a high level. This makes Cassandra column-oriented rather than row-oriented. You may have heard of SQL databases before, and the label NoSQL, proactively adapted to mean not only SQL, is a broad umbrella comprising of many different technologies. Cassandra, as a wide column store, falls into the not only SQL category, as it does not support several features that an SQL database would, while offering much more schema flexibility. NoSQL databases span multiple types and use cases, so let's take some time to look at how Cassandra stores data. Cassandra uses the idea of data partitions. Each partition holds some of your data and is indexed by a partition key. The goal is to design your data and access cases so you access as few partitions as possible in a query. Also note that joins from SQL are not possible. The norm in Cassandra in these cases is to use either data denormalization, where the data from both partitions is copied into a third, or a lookup table with partition keys. Data modeling is a key aspect of Cassandra database design. There's a link to learn more in the description. There is also the concept of clustering keys. These are columns chosen at table creation that can be used to sort. Cassandra does not support sorting on columns that are not cluster columns. Designing your clustering keys is an important part of Cassandra database design and modeling. A feature that makes Cassandra stand out is the Cassandra Query Language, or CQL. CQL is a query language that allows you to query your Cassandra data in a way that is very similar to those familiar with SQL, but still lacks some SQL features like joins when adding a few of its own. It should provide a familiar interface to a less familiar database for those coming from a SQL background. To learn more about CQL, check out the link in the description. Cassandra is distributed, meaning it runs on several different machines that may or may not be co-located, but presents the user with a unified API. Cassandra is also decentralized, meaning that the Cassandra cluster is homogeneous. Each node has the same capabilities as every other node. Cassandra uses a gossip protocol between nodes to sort out things like node status and health, who gets what queries, and achieving consistency. Scalability means that you can add nodes to your Cassandra database without taking the database down. This means you can scale up your database as you need rather than having to plan a maintenance to add nodes. Cassandra is an AP system on the CAP theory scale. More on that in the description. Essentially, this means that Cassandra has a focus on partition tolerance and availability with what's called eventual consistency. However, you can tune Cassandra to be more readily consistent at the cost of performance. These are discussions and trade-offs to be made when choosing your database solution. Fault or partition tolerance means that Cassandra databases can handle failures at the network partition level. Even if you lose some of the messages in the failure, the database can continue to function. If a node goes down, the other nodes will use a gossip protocol to course correct. The general idea is high availability, even in situations with high or intermittent network latency. Cassandra was designed for Facebook's index search, lots of data over many servers that needed to be indexed for quick retrieval. It's here that the relevance of a column-oriented database in the new big data shift really comes into play. Column-oriented database can optimize analytical queries and handle large volumes of data. This enables faster data retrieval, improved compression ratios, and enhanced scalability. This makes them well suited for the complexities of modern data-intensive applications. Cassandra was built to be distributed across multiple servers that weren't necessarily co-located. Any use case where you need lots of data in lots of places, Cassandra could be a good bet. Cassandra was designed to be highly fault and partition tolerant, creating a high availability database. Any use case where you need strong uptimes from your database is a good fit. When you need to make tons of writes to your database without giving up speed or accuracy, Cassandra has you covered. Some companies are using Cassandra to handle petabytes of data with writes coming in at hundreds per second. Thank you for joining me, and I hope you learned enough about Cassandra to have a good chat at any event or conference you may go to. If you'd like to learn more, you can go ahead and subscribe below, and you'll see more videos like this in the future. Thank you very much.